Hey everyone, in today's lesson we are looking at powers of products and quotients. So our learning intention is that we're going to extend the power of power rule to apply it to terms involving more than one pronumeral or terms that are in the form of a fraction. Now, in the last lesson, you learnt that applying the power of a power rule to a term which has a coefficient means you had to apply it to the coefficient as well because it was inside the brackets. So if we are looking at 2x cubed or to the power of 4, this 2 is inside the brackets, which means the 4 had to be applied to the 2. So we get 2 to the power of 4, and then we multiplied these two terms here together, or two indices here together, and we had x to the power of 3 times 2. So our final term was 16x to the power of 12, because 2 to the power of 4, or 2 times 2 times 2 times 2, gives us 16. Now, we need to remember that a pronumeral is just the same as a number, and therefore it has to follow the same rules. So if we had the term AB inside the brackets, then that means it's A times B. So we've got two terms there, which means our power has to be applied to both terms. So we have A to the power of n times B to the power of n. So let's look at how that works with some examples. If we have got AB to the power of 4, then that 4 has to be applied to both terms inside the brackets. And we are left with A to the power of 4, B to the power of 4 as our answer. If we look at B, we've got x squared, y cubed, all squared. So again, we're going to take this 2 and we're going to multiply it to that 2 there, and we're going to multiply it to that 3 there. And we're left with x to the power of 2 times 2, y to the power of 3 times 2, which gives us x to the power of 4, y to the power of 6. If we have a coefficient added as well, we're going to use the same rules, only this time this 5 needs to be applied to all 3 terms that we now have inside the brackets. So if we have minus 2 AB 4 to the power of 5, then we are going to multiply, or we're going to add that 5 to every term inside the brackets as a power, which means we are going to get minus 2 to the power of 5, A to the power of 5, B to the power of 4 times 5, which gives us minus 2 to the power of 5, A to the power of 5, B to the power of 20. And now we're going to focus on this minus 2 to the power of 5. We know that it has an odd power, so our answer is going to be negative. And then we have 2 to the power of 5, so we know 2 to the power of 4 was 16, so 2 to the power, 16 times 2 gives us 32, A to the power of 5, B to the power of 20. And that is our final answer there. Doing one more example, we're going to continue this, and the rules are going to stay exactly the same. We have got minus 3, x to the power of 4, y squared, all to the power of 4. So just like before, we're going to multiply that 4 with every term as a power for every term that we have there. So we are going to have minus 3 to the power of 4, x to the power of 4 times 4, y to the power of 2 times 4. So we have minus 3 to the power of 4, x to the power of 16, y to the power of 8. Now, like before, we're going to focus in on our coefficient here, and we've got minus 3 to the power of 4. This time, our power is even, which means our answer is going to be a positive number. So we've got 3 to the power of 4, so 3 times 3 times 3 times 3. So we have 81, x to the power of 16, y to the power of 8. And that there is our final answer. So that is what happens when we are multiplying products or using the power of power rule on products inside the brackets. You can see all we do is just apply it to every term inside. So when we're looking at it in fractional form, it's going to be exactly the same thing, where this power of n needs to be applied to the a as well as the b. So a over b to the power of n is going to be a to the power of n, b to the power of n. Again, looking at a couple of examples here, if we have got 2 over 3 all to the power of 2, then we are going to multiply the one that's already there by that 2. We're going to do the same on the bottom here, and we are going to be left with 2 to the power of 2 over 3 to the power of 2, which gives us 4 over 9. If one of our terms in the fraction is a pronumeral, it makes no difference. We still do exactly the same thing. So we have got x to the power of 3, or x over 3, all to the power of 4. So again, we're going to multiply that 4 to both terms' powers, and we're going to be left with x to the power of 4 over 3 to the power of 4. Involving a coefficient just means we have another term to take this power across to. So what we are going to have now is we are going to have 3a over 5 all to the power of 3. We need to put that 3 onto the 3, put the power of 3 onto the a, and put the power of 3 onto the 5. You can see all we're doing is applying that power outside of the brackets to everything inside the brackets. And we are left with 3 to the power of 3, a cubed over 5 to the power of 3, which gives us 3 times 3 times 3 is 27, a cubed over 5 times 5 times 5, which is 125. If everything involved coefficients, we're still going to do exactly the same thing. That 2 is just going to be multiplied to every power that's already there. And we are going to be left with x to the power of 2 times 2, y to the power of 3 times 2, all over z to the power of 4 times 2, which gives us x to the power of 4, y to the power of 6, over z to the power of 8. And using our final part there where we have a coefficient, same rules apply. We're going to have minus 2 to the power of 2, a 3 to the power of 3 times 2, all over b to the power of 2 times 2. And we're going to have minus 2 squared, a to the power of 6, b to the power of 4, and as before, we've got an even power on a negative number there, so that is just going to become a positive power, or a positive term, and we're going to have 2 squared, which is 4, a to the power of 6 over b to the power of 4. So that is how we use the power of a power rule when we have products or quotients inside the brackets. Have a go at the exercises that have been set, and remember, if you have any questions, ask your teacher.